For centuries, universities were almost exclusively for the wealthy and the privileged. They taught classical subjects such as philosophy, theology, Latin and Greek, and prepared students for a lifetime of learning rather than a lifetime of work. But in the 19th century, the Industrial Revolution created a demand for people with practical knowledge. Suddenly, the world wanted scientists and engineers rather than philosophers or theologians. To meet this need, a new kind of institution emerged, known as a technical college. Here, students could further their education while acquiring skills and technical knowledge relevant to their chosen career. ETH Zurich, established in 1855, was the first such institution in Switzerland. Today, it has around 18,500 students from over 110 different countries. It is a leading centre of science and technology and is regularly rated as one of the top universities in the world. For over 160 years, it has linked academia with industry, a tradition that began at the height of the Industrial Revolution. Professor Nicholas Spencer, president of the ETH Research Commission, explains why.
There was a growing feeling in the country that there was a need for teaching engineering. The rest of Europe was building railways, and there was a danger they were going to build them around Switzerland. And if Switzerland wanted to be part of this developing movement, then Switzerland needed railways, they needed engineers, they needed tunnels. And the problem was there weren't any engineers. And the universities at that time said they weren't prepared to teach engineering, mostly for cost reasons. And they said the responsibility was with the federal government to found an engineering school, and that's what we became.
However, the university quickly grew. Today, it is spread across a number of campuses and offers a wide range of subjects across 16 departments.
We have the full range of engineering subjects, mechanical engineering, electrical engineering, etc., and civil engineering, of course. And then we have all the natural sciences, chemistry, physics, biology, and then we have sciences that are somewhere in between, like the earth sciences or material science, my own area. And then we do also have some support areas in the humanities. So we have full professorships in areas such as literature, but these are really intended to be rounding out the education of the engineers and scientists rather than offering a full program in those areas, which is what is done by the more classical universities in Switzerland.
Over the last 160 years, ETH Zurich has grown from a small specialist college to one of the most prestigious universities of science and technology in the world. It has produced an astonishing 21 Nobel Prize winners, including the 20th century's most famous scientist, Albert Einstein. How does Professor Spencer account for this extraordinary success?
Well, I think there are three main reasons. One is that it's had the support of the federal government from the beginning, and it's still very well supported by the federal government to a level that most countries don't support their universities. So that's a very good starting point, but that's not enough. There are examples of universities that are well supported that don't have that reputation. The other is, from the very beginning, it's been international. Even in the middle of the 19th century, there were many professors who weren't Swiss, and we now have 60% of our professors who are not Swiss. I think this makes a big difference in outlook, because we're always trying to recruit the best in the world in any subject. I think the third reason is that professors are really given a very high degree of autonomy, which means they're given a good situation in terms of doing research, they have good students at their disposal, and they're given complete freedom to work on whatever projects they think are right.
ETH Zurich has always been on the cutting edge of both science and technology, and this emphasis on innovation is reflected in its teaching.
We're looking at a lot of different new trends in education and trying some of them out in our teaching offerings right now. And one I particularly like is the inverted classroom, where the students arrive prepared for the lecture. So they're not arriving ready to learn, they're arriving already having started the learning process. For example, by watching videos or looking at material in books or on the web the night before and asking questions in an online forum before they get to the class. And then the first thing that's done in the class is to discuss the questions they have on the material they've already learned. So we're doing that right now in an experimental class over this summer. And we have high hopes that that's going to be a new mode of teaching various techniques in material science in a hands-on way.
Since it began, ETH Zurich has adapted to meet the challenges of the modern world. It has continued to develop and evolve in both its research and its teaching methods. This ability to change with the times has made it one of the leading science and technology universities in the world.